Welcome to the presentation on Turing Machine Variants. In this module, we will explore different types of Turing machines, focusing on multi-tape, multi-head, and non-deterministic Turing machines. Let's dive in. Before we delve into the variants, let's briefly review the standard Turing machine. A Turing machine is defined as a 7-tuple computational model. It consists of a set of states, an alphabet, tape symbols, a transition function, a start state, an accept state, and a reject state. This can be formally represented as M equals Q, sigma, gamma, delta, Q, QCC, QC, where each symbol represents a component of the Turing machine. Now let's explore our first variant, the multi-tape Turing machine. This machine is an extension of the standard model, equipped with multiple tapes. Each tape has its own independent read or write head, allowing for concurrent operations. As you can see here, each tape operates independently. One tape contains a B, C, and D, while the other tape contains X, Y, and Z. Let's discuss the equivalence of multi-tape Turing machines. Multi-tape Turing machines possess the same computational power as single-tape Turing machines. Additionally, they offer quadratic speedup for many algorithms, enhancing their efficiency. Next, we will discuss the multi-head Turing machine. This type of machine features a single tape but uses multiple independent read or write heads that operate simultaneously. As you can see, head 1H1 is on the first A element, and head 2H2 is on the fourth D element. Let's explore non-deterministic Turing machines. These machines allow for multiple possible transitions from a single state symbol combination. For example, in state Q1, with input A, the machine can choose to transition to either state Q2 or Q3. Here is the acceptance criteria for a non-deterministic Turing machine. An input is accepted if at least one computational branch reaches an accept state. Conversely, an input is rejected only if all computational branches reject or loop infinitely. In conclusion, all Turing machine variants possess identical computational power to the standard Turing machines. This equivalence can be represented as standard Turing machine is equivalent to multi-tape Turing machine is equivalent to multi-head Turing machine is equivalent to non-deterministic Turing machine. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.